these two zeros. What do you want to do?
These two zeros.
How?
Just to change the first and the third row.
The first and the third?
And not row, sorry, column.
That's okay, because you gotta find if they're dependent or not. So it doesn't matter if you switch the columns. So that's kind of tricky, but think about it. If you switch the columns, what changes? Nothing. If you switch the columns, really nothing changes. You gotta switch all the columns. You're just switching the first and the third coordinates. You can just switch the first and the third. You can say, okay, now my first coordinate is the third coordinate, and third coordinate is the first coordinate. Big deal. Nothing. If you get one relationship, you still keep that relationship. You can switch columns. Nothing you gotta do. You don't have to do no minus nothing. And you're not looking for the determinant. You don't have to put the determinant up front and divide or whatever. But you can definitely switch columns. That's okay. So you can switch maybe the first and third. I'm okay with that. So you can switch the first and third columns. And nothing to do with that. No extra notation, nothing. Just to switch it. This is the first and that's the third. You can switch. This becomes the third and that's the first. So you have 1, 0, 0. 2, 1. And or you can just shift the third to become the first. Doesn't matter.
We should also do U5 to be in place of U2.
Say it again?
Like replace U5 and U2.
These two? Why? You mean the rows? Let's just do this first. So you can put, that's okay, 0, 3, 6, 10, 1. And here's 1, 2, 3, 7, 1. 1. You don't have to do this. Just a suggestion. So now, do you want to go for these two zeros? Okay. So it's still U1, U2, U3. Nothing changes. You just switch the coordinates. That means nothing. For the dependence and the formula, it means nothing. So now you're going to keep the first three rows. So it's still going to be U1, U2, and U3. And you're going to have 1, 0, 1, 1, 1, 0, 3, 2, 4, negative 1, 0, 6, 3, 3, 5. Now you're going to be combining U1 and U4. You're going to do 2. You're going to do U4 minus 2 U1. You're going to do that. 2 minus 2, that's going to put 0 here. And 10 minus 0 is 10. 7 minus 2 is 5. 9 minus 2 is 7. And 6 minus 2 is 4. Are you okay with that? And the last one, you want 0 here. So we're going to do U5 minus U1. So 1 minus 1 is 0. 1 minus 0 is 1. Now you're getting 0 and 0. And 0. Okay, so everybody okay so far? Listen up. Now we're going to do a slight combination of the other method. Not really. The other method worked like what? You would say, okay, I can do 1 and then eliminate this and this. You're going to do that. You're going to do that. Why? Because there's nothing you can do with this anymore. If you get any dependence, it's going to be in the second, third, fourth, and fifth row. You're not going to get it in the first. You're always going to keep the first row. You understand? Whatever you do now, whatever you did, I'm sure you kept the first, and then you kept the second row and the third row and so on. There's no need, and here you can see the relationship, why it works like it works, the other method. So I suggest we don't need this no more. You can just eliminate the first row and the first column. There's no need to keep track of that. Okay? So you can work with 4 by 4 matrix. Is everybody okay with that? Why not? Because whatever the dependence you're going to get, you're only going to get it, you're not going to get it in the first row. Because the first row is going to keep 1, 0, 0. And these zeros will always be zeros. There's no need to keep track of it. That's how the second method works. That's why the second method is equivalent to the first. You may want, but there's no need. There's no need. You're going to get one of these will be all zeros. And I guarantee it's not going to be the first, the value. So who cares about the first? You don't know which one is going to turn out to be all zeros. So you can keep working with that ones. Take a look at it. Let me know if everybody's okay with that. You may if you want to. You don't have to. And if you do that, you want to call this, you want to call this first, second, third, and fourth, or second, third, fourth, and fifth? First, okay. So this is also okay, or you want to still keep track of this. You don't have to. You can do what we did before: first, second, third, and fourth. At the end, you can take care of everything. Yes, I'm right. Yeah, but one advantage, listen again, one advantage is maybe, if you're lucky, this determinant is not going to be zero, then you don't have to do it. And you don't have to keep track of all the combinations. But you can easily do it if it is zero. Got what I said? It's up to you. If it turns out, so a lot of times it's not zero, and then you don't have to do all this. But this is like an in-between. It's really up to you. I'm just trying to suggest stuff to you. But you can keep the first and then just do the whole thing. Make these now. This is the data. Now you're going to keep zeros out of the elements. Okay. Everybody okay? Yeah. So what are you going to do? You want to keep the last one maybe? That seems the best one to keep. So now the last one is 4. If you want, for one more step, you can keep 0, but you don't need to. So you don't need that. Now, do you want to do it like that? Or you want to do like keep the 3 here and make 0s here? No, you want to keep it like this? That's fine. Okay, so what are you going to have here? 10 and 1, so you're going to do 10 times the 4, or maybe you can do third minus 10 times the 4. 10 minus 10 is 0. 5 minus 0 is 5. 7 minus 0 is 7. 4 minus 0 is 4. going to be 5, 7, 4, 3, 3, 5, 2, 4, minus 1. Agree? They're not going to change because you need to go combining these zeros. That means that when you combine with these, then what it really means is that you can also, in this 4 by 4 matrix, look, you can start at 1, and you can eliminate this row and this column, because they're all zeros here. Just like we eliminated this column. Because really nothing changes when you do that. This remains to be 5, 7, 4, 3, 3, 5, 2, 4, minus 1. So no need to do that, because you're not going to change anything. You're just going to get what you got before. So what you can do is you can eliminate this and this. Let's try that. You don't have to do this. I'm just suggesting as one way of doing it.
Wouldn't that take up the final formula when we're trying to find?
Say again?
The final formula when we're trying to find
The final formula, yes. And that will affect the final formula. For the final formula, you would have to know how do you combine these with the fifth. That's true. So you can do, it's not going to affect, but you will need a formula. So maybe we can keep that. I don't know if you can go and switch here. But definitely we should keep but that's what's going to happen here. So you're going to keep the 4, 1, 0, 0, 0, and everything is going to be here like 5, 7, 4, 3, 3, 5, 2, 4, minus 1. But it's going to be different. The formula is going to be different. How? This is going to be, you're going to be combining 3 and 1. So this is going to be first minus 3 times the fourth. This is going to be second minus 6 times the fourth. And this is going to be the third minus 10 times the fourth. Okay? And now, you can call this first, second, and third. This is all that you can save a few minutes by doing so. You don't have to. You can do what we did with the 3 by 3, and that's, what we always do. Keep the first. This is what you can always do. It takes a few minutes longer, but, that method always works. Maybe I should have done the long way. Did you guys get lost here or no? No? Anybody? Do the next one. Next class without doing this. You can always do it like this. Look, the way you can do any 3 by 3, 5 by 5, 7 by 7, you can keep this. Here it's 3 by 3 now. So you can keep always the first row, and then change the second and third so you get zeros here. Very simple method. It always works. So how are you going to get 0 here? You can do 3 times the first minus 2 times the second. 3 times 2 minus 2 times 3. Everybody agrees with that? 3 times 4 is 12, minus 6 is 6. Minus 3 minus 10 is minus 13. Okay with that? How do you get 0 here? You've got to combine 2 and 5. So you can do 5 times the first minus 2 times the third. 10 minus 10 is 0. 5 times 4 is 20. Minus 14 is 6. Minus 5 and minus 8 is... Got that? You can stop it. Done. Usually you will have to get 0 here, but there's no need. Look, this is equal to that. Got it? So if you call that now the new first, second, and third, but there's no need to do that. You can observe second row is equal to the third. Got that? You're done. Let's get the dependence. You agree that the second is equal to third? Let's unwrap now. Okay, what's the second? The second is 3 times the first. This is the previous step. 3 times the first minus 2 times the second equals 5 times the first minus 2 times the third. Agree with that? Yeah? So do you want to simplify this? Why not? Okay. So you can combine this and this. 5 minus 3 is 2 times the first, and this you can move here, plus 2 times the second, equals 2 times the third. That's what it is, correct? I'm going to put it here, because it's on the same level. So this just means when you work this out, you're going to get what? First plus second equals third. Check this. Is that what you're getting? Because you'll be combining 3 times the first and 5 times the first. You get 2 times the first plus 2 times the second equals 2 times the third. Divide both sides by 2. Is this what you're getting? First plus second equals third. Yeah? Come on, guys. Is everybody okay with this? Okay. Now, but that's not U1, U2, U3. Let's see what is it. What is these 1, 2, and 3 now? There, these are these ones, correct? That's where we are now. This, 1, 2, and 3, were these ones. Now we're here. Second. This was the first step, second step. Now, first, look, what's the first? It says here, the first is first minus 3 times the fourth. Agree? Is everybody okay with that? First minus 3 times the fourth. What's the second? Second minus 6 times the fourth equals third. What's the third equal to? Third minus 10 times the fourth. New relationship. How does this work out? Here's the first, here's the second. So we're getting first plus second. How many third do we have? Only 1/3 here, correct? How many fourth? Minus 3 minus 6 is 9. So plus the fourth equals the third. I'm getting something like this. You can put it all on one side if you want. It doesn't matter. Is that what you're getting? Everybody agrees? Where are those first, second? It's these ones. First, second, third, and fourth. It's the next. These, they're here. First, second, and third. Now in this second line, where are those? It's the second, first, second, and third. It's here. Now where are these? First, second, and third. Got it? And fourth. What are those equal to? The first is what? U2. Let's get it. This first is U2 plus. What's the second? U3. What's the fourth? It's here. U5 minus U1. And what's the third? U4 minus 2. That's the end of it. As soon as you get U's, you're done. But you should simplify. You should combine likewise steps. So you get U2 plus U3 plus U5. You do plus 2U1 to both sides. So you're getting plus U1. You can move this on the other side if you want. Or you can leave it there, equals U4. That's what you get. And that's what it is. Got that, guys? So the answer key is what? Yes or no? They're dependent. And this is the dependence relationship.